Hey everybody, this is your 4-6 pre-calculus math Excel video. So to start with, we are talking about polynomials and rational functions. This section involves graphing and inequalities. So if you were asked for where y is greater than 0, then that means above the x-axis. So that'd be up. And if you're asked where y is less than 0, that is below the x-axis. So now let's just suppose you have this random function that hits and touches the x-axis and crosses here. So if your function, whatever it is, if the question says greater than 0, you're going to want to use F1 to graph it, not relation. And remember that if it's less than or greater than, then you have to use parentheses, not brackets. If it is less than or equal to or greater than or equal to, that's when you use brackets. Now the exception is with negative infinity or positive infinity. So again, say we had greater than 0. So you want to see where it's above the axis, so that's here, and then you got to stop, and then you have to go here, and then you stop. Well, in all these places, this would be negative infinity, and then this place would be 0 with a parentheses because we had to stop there because it's greater than instead of greater than or equal to. And then we start again and go 0 to 5 with parentheses. Now on the other hand, if it were greater than or equal to instead of greater than, then you just say negative infinity to 5 bracket. Remember, if it's the equal sign underneath, we just use the bracket. Okay, so you will need to pay attention to whether the interval is closed or open or half of each. There is solution set notation, which has to do with inequalities, and interval notation that has to do with parentheses or brackets that's used. So these are your steps. Write the equation so that you have 0 on the right, and they want you to get a single quotient. You want to determine your real numbers where it equals 0, and if it's rational, where it's undefined. Remember to use menu 6.1 or factoring to find out the boundaries. You also want to use the numbers in the previous step to separate into intervals. You could test points either by hand or through the table, or use your graph. I'm going to demonstrate the part about through the table in a problem. But basically, if the value of the y, coordinate is positive, then it means above, and if it's negative, it's below. Okay, so again, in this section, we're going to solve polynomial and rational inequalities, both algebraically and graphically. Inequalities degree 3 or higher. Quadratic ones were last year in Algebra 2. And again, the closed interval means it's brackets, and that's when you have your less than or equal to's. The open interval is with parentheses. You do have to order it like least to greatest, so just keep that in mind. You want least to greatest. There are times where you could have parentheses on one side and bracket outside on another, which would indicate a less than x less than or equal to b. One case in particular is if it's negative infinity, but you could also have another, just a random parentheses from an asymptote or something, or a hole in the graph, but then on the right side end up as a bracket. And then you can have the other way around also. Okay, so again, to solve it, you want to decide where it's above in this case. So in this case, because it's above but not equal to 0, you have to have a hole there and a hole there, for your interval. So we would just say -3 less than x less than 1. And then for the right side, we'd have to say x greater than 1. So that has to do with your solution set. They just said the set of all x's such that those two conditions are true. And then with interval notation, it'd be -3, 1, union 1, infinity. Now on this side, when we're solving the inequality, you're going to want to have 0 on one side. Don't divide by x. You would have 1 on the right. Also would lose a solution, a 0 solution. So here we're factoring out the x once it's over, and then from there they did the difference of two cubes formula. Now I don't have that memorized, but I do know that if it's x cubed minus 1, you're going to start with x minus 1. And then I know that it switches the sign. But in this case, I would probably just graph it. So let's just graph this. X up arrow 4 minus x. So I'm not going to mess with the greater than symbol. I just press enter, and there it is. And so then I do menu 6, 1. Between here and here, there's 0, 0. And menu 6, 1, there's 1, 0. So those are the 2 points we're interested in. Now here they're saying do a table, choose values, and so forth. And you can. I mean, there's nothing wrong with that. But you could just look at the graph and see where it's above or below. As I mentioned on the other side, you could look in the table also. So there's 1, 0. So after it, you have positive numbers. Those are numbers you could like say you're testing. Well, they're positive. Now, the problem with the table is you don't get things like a half. You see these two things in a row with 0, 0 and 1, 0. So the table doesn't completely help you, but then on this end, it's positive again. So just use all your resources. You could use the table. You could zoom in or zoom out sometimes. Like here, I can easily see, even without changing table values, that this bumps down. You can do window, zoom in if you have to. So there you can really easily see it's below. So 0 to 1 is where it's negative. So that's why in here we say positive, negative, positive. Again, if you wanted to do the math and plug the x's in where it says f of whatever, you know, this is your x value, this is your y value, you can do that. So if you wanted to plug in a half and get -7/16, you could, but I would just use the graph. It's much easier. So since we want to do greater than, then that's where it's positive. So that's the -infinity 0 and the 1 infinity. Okay, so this one just shows you another example, and this time they want greater than or equal to. So first you'd set your denominator equal to 0 because it's a rational function that has vertical asymptotes, or it could be holes, but in this case it's definitely a vertical asymptote. And we want where it's above. So basically from the asymptote section, which is the -2 in parentheses, stopping at 1 with a bracket. So this is the one where we would call it's half open, or you could say half closed. So the reason why it's a bracket here is because of that. But it is definitely a parentheses for the -2 because that's your vertical asymptote. On this end, on this example, they brought the terms over, got a common denominator, and worked it out. Again, I would probably just graph it. And again, there's where they tested the values. So the part for the steps we've already discussed. It's basically put 0 on the right, find your real numbers, break it into intervals, and make a table and see where it's positive and negative. Okay, so now moving to the actual problems. For number 1, it says 2 minus 4x less than or equal to negative 6. So our first goal is just move it over, so we add 6 to both sides. And then we have 8 minus 4x less than or equal to 0. So one way to work it is algebraically, and that's where you'd factor out the 4, so you're left with 2 minus x. And then if you're dividing by 4, that cancels. So you have 2 minus x less than or equal to 0. So at this step, instead of multiplying or dividing by negative 1, because remember, when you do that, you got to change your direction. I'm just going to add x. So that's add x, since multiplying or dividing by a negative switches the direction. So I just did it this way by adding x, and then I just reversed it because we always put the variable on the left. So it's opening to the x, and so it's pointing to the 2. And so then that'd be bracket because it does include it because of that equal sign. So that's the algebraic way to do it. The other way to do it is graphically, like using 8 minus 4x less than or equal to 0. So we just go we go to the graph, 8 minus 4x, press enter, and you want less than or equal to 0, so you can see that's down right there. Again, if you wanted to, menu 6, 1, like that. Now the difference between the graphs is this is your two-dimensional graph, which is your x and y, which is what we always use. Compare that to this, which is just a number line. This is just a number line. Okay, so now moving on to this one. When it wants greater than, you're going to have parentheses. So if you're like looking at the problems, the first step would be think, is it going to be parentheses or brackets? Always do that because you're going to be frustrated if you choose the wrong one. Like you may have the right numbers, but you use the wrong symbol. And also think, so that's step 1. Step 2, think, is it above or below? Okay, so in this case, we have greater than, so it's above. So left of negative 1, so that's your negative infinity, negative 1, and between 1 and 3, so union 1, 3. Again, that had to be with parentheses because it said greater than. Now on this one, it wants less than or equal to, so you're just going from there to there with brackets. And after the 3, so bracket 3 comma infinity. So again, you have to use the brackets on the actual numbers, negative 1, 1, and 3. On this one, we have x squared times x minus 3, and you want less than 0. So again, you want to do parentheses, and you want to do below. That's your two parts. So if you want below, that's here. Now, it's parentheses and not brackets because it can't actually equal 0. So you have to split it. So you're basically going to go from here to here, and then you're going to go from here to here. So what they have is negative infinity to 0, union 0, 3. So again, why you can't just do negative infinity 3 is because we want less than 0, not less than or equal to. Okay, on this one, we have greater than or equal to, so it's going to be brackets and it's going to be above. Now, that's going to be with negative 2 and it stays above. I mean, yeah, it stops at 3 right there, but it, technically you could have it continue because it's greater than or equal to. And so that condition where it is 3 with y being 0 is true. So that's basically just like x greater than or equal to negative 2, and that's why you put your bracket negative 2 comma infinity. Now, just as a review, as what we've talked about before on some other sections, if this is like x plus 2, then your multiplicity is 1 because it's just the exponent. And we said before, if it's 1 or 3, like if it's odd, then it's going to cross. And if it's even, like multiplicity 2, then it's going to touch. So over here, we're crossing, and here we're touching. So just reviewing a little bit about what we've done. Now on this one, we want greater than or equal to, so we want brackets and we want above. I'd pretty much make a note on all of them if you would put bracket above. So here we want, now I say that, but if it's infinity, we'd use negative infinity comma negative 2 bracket. So when I say brackets, I mean brackets on the numbers. So it stops there and then from 3 over. So that's your negative infinity, negative 2 with a bracket, union bracket 3 infinity. That union again means or. Now again, I don't recommend using relation, but if you did, it would look like this, which I think is not that useful. Let's try it. Press delete, go to 8 or 6 for relation, 3 parentheses x minus 3, and then x plus 2 cubed. And then I'll do greater than or equal to 0. So that's control equal greater than or equal to 0. Whoops, that's the exponent. So I need greater than or equal to 0. Let's just see if it shades. Okay, it did. So that's the shading on it. And so you can tell it's, true in those cases. But because it shades both, the top and the bottom, I don't like it. It's just my personal preference. Also remember, the more shading, the quicker your battery's going to die. So I would just look at the x-axis and say this means above, and this means below. So to me it's a lot easier just doing it the other way. Now on number 6, it says solve the following inequality. You can get your x-intercepts and zeros really easily like we did before. Remember, just flip your sign. You can even remember that this part would be touches and this would be crosses. But I'd say graph it. Graphing, when in doubt, graph. When in doubt, graph it. So always have your calculator ready to graph something. So let's go back to the graph on this. Especially if you're asking a question, it'd be nice if you had your calculator ready. and maybe a little sheet of paper and pencil or pen. X minus 9 squared times x plus 3. Okay, so there it is. You might need to zoom out, but I think I can see it pretty easily because we did the math also, and if we know it's 9, it's right there, and we already said it's touches. So the only tricky part kind of is this kind of looks like a straight line, and so you might want to go in your table and say, okay, it's positive on right of the negative 3, which means up, and it's negative left. Now the other thing, just one quick hint, besides use the table also, is you can also do menu for A, which is zoom fit. Because I would recommend doing zoom fit if it looks like a straight line. Because then you can actually see if it's a good graphing window, like in other words, whether everything fits on the screen, and here it does. So sometimes that helps, sometimes it doesn't, it just depends. If you're just looking at below, it does help, you know, but if it's a really narrow dip, then it wouldn't help. So just use all your technology on your calculator and use your mind. Okay, so on this one, number 7, we have x cubed minus 5x squared. Again, we do want less than, so it's going to be parentheses, not brackets. What they recommended on this on the notes, if you remember, is to factor out your greatest common factor, because then we can, you know, find out our zeros algebraically. It's always a good idea to know how to do things, because remember, some parts of the SAT are with a calculator and some parts are without. So I do just say equal 0 because it's easier, because you don't have to worry about reversing the direction and then look back at the problem when you're done. So there it is. And oops, when we go to the graph, x to the third power minus 5x squared. There you go, and we want below. So that's this part. Well, it's basically the whole thing, except you have to split it at 0. So it's basically negative infinity to 5, but you can't use brackets, so you have to split it at 0. Split it at 0. That's this right there. That's what I call a split. Because even though it looks like it's below, in the table it's actually 0, 0. And our inequality says less than, not less than or equal to. Okay, and then number 8, we're factoring out an x, so we get 0. Take your square root of 4 and you get plus and minus 2. And again, ask yourself, are you less than or equal to? Are you greater than, or are you greater than or equal to? In other words, are you using brackets? In this case you are, and in this case it says less than 0, so you're below. Okay, this one was just parentheses and below. Okay, so then you just graph it and you get it. X, oops, I put W, x to the third power minus 4x, enter, and it's below here and also between 0 and 2. So from negative infinity to negative 2, stop, and then there. If you want to, take a little sheet of paper, whatever, and you can see that's the area we're interested in. So anything left of negative 2, so make sure on that negative 2 you put a bracket, and then from 0 to 2 with brackets. Okay, on this one, again, we're going to want to graph it, but we can tell our x-intercepts or zeros of the graph. It's less than or equal to, and so we're going to use brackets, and this one's below. And there's my note. It's funny. I don't recommend using relations. So let's do it normal first. X minus 3, X minus 4, X minus 6. So there you go. And it's going to be 3 and 4. And then, well, okay, we want below. So we want negative infinity to 3, and then we want 4 to 6. Now you know on Math Excel they can easily change the numbers or the direction. And they can even say this time I want less than instead of less than or equal to. So just read your problem carefully. Now again, addressing my note, if I did relation x minus 3, x minus 4, x minus 6. This time we want less than or equal to 0. It's going to look like that, which to me again is weird. I guess it makes sense because it's negative infinity to 3 and then 4 to 6. But personally, I don't recommend that. I'll just say below the x-axis. Okay, on the next one we have x cubed minus 7x squared minus 30x less than 0. So again, it's going to be parentheses and it's going to be below. Our first step when you do it algebraically is to factor out the x, and then you can think, I know I can do 5 times 6 to get 30, but I really want to do 10 times 3, because since it's a negative 30, I need opposite signs. And so then I can say, well, I know if I have 10 and 3, that my 10 would have to be negative because my middle term is negative 7. So this one has to be negative and this one has to be positive. Now, if this were a plus 7x and minus 30, you'd have to put the plus here. So if you ever have a middle term that's negative, make sure your bigger number is negative. So that's the algebraic way. Again, if you wanted to test values, like you could test negative 10 because that's left of negative 3. You could test negative 2 because it's between there and 0. And you could test 5. And if you even had to, you could test 15, you know. So remember, you can test certain numbers or you could test through the graph. So speaking of the graph, x to the third power minus 7x squared minus 30x. There's the graph. Now, when we did this algebraically, which is what I would recommend, at least to start with, you only see 2 answers. Sometimes you got to zoom out or do menu 4A. Let me try that first, and that showed it a little bit. Yeah, that's pretty good. When you do menu 4a, it doesn't change your width at all, but it does change your height. So we could have done that, or gone from our standard window and just did menu 4 and click, and so then you can see it. And then you can do menu 4a and see it. So now it looks like on this one, at the exact spot, remember when I said sometimes menu 4a doesn't help you? Here you can't tell how far up it is because the scale is 1,000. So just be careful when you're messing with your settings. I would probably just go -20 here and +20 here. So then you can see them. Or you could go to your table and just see where it's negative. Like, looks like all these are negative until 10, and then it's positive. And then on the other end, these are negative throughout. Okay, so this is -infinity, -3, union 0, 10. Okay, now on this one, you have x to the 4th greater than 121x squared. Again, don't divide. You want to subtract and set it equal to 0. This one would use parentheses, and it's above. So we factor out our x squared, and we're left with x squared minus 121. I think on this problem all the time it's going to be a perfect square, whether it's 121, 144, or something else. So when you take your square root, in this case you get plus and minus 11. So again, let's graph it. X to the 4th minus 121x squared, enter. Now since we know the square root of 121 is 11, you might want to like zoom out a little bit, and there you can see it. And again, it's kind of like you might want to do menu 4a to see which side is down and which, like, is it increasing here or is it decreasing, like caving in? Or just use your table. There's a lot of different ways to do these. So with the table, that's pretty negative number right there, and then it's still negative, and then after 11 it's positive. So that part's above. And I guess I didn't go quite far enough. If I went to -11, it was 0, and then these are positive. So personally, I prefer using the table to zooming out or doing menu 4a. But again, you do whatever you like best. So zoom out or use the table. And I really do like the table the best. Okay, so this one is going to be parentheses and above, because we have x to the 4th greater than 256. We subtract it. Now, if you want to, you could take the 4th root of 256, because like the square root of 256 is 16, and then you take the square root again and you get 4. So that's one way to do it. The other way is to break this up into the difference of two squares. So x squared minus 16 and x squared plus 16. Now this left side is also another difference of two squares, but this side would be the imaginary. So we just care about the 4 and the -4. Again, you'd go back to graphing it. X to the 4th power minus 256, enter. It's right there. And you want above, so if we find our -4, then to the left of it, it's positive. So that side's up. Between there is down. And then to the right of 4 is up. And since we wanted above, we're doing left of -4 and right of 4. On this one, again, we're doing below, so we use the parentheses on this one because it's less than or equal to. So we have our 2, 3, and 4. X minus 2, X minus 3, X minus 4. Okay, so there's your 2, 3, and 4. And we want below, and so it's up to 2, but with a parentheses. So that's your -infinity 2. And it also dipped down between 3 and 4. So on all of this part, you had to use parentheses, not a bracket. Now on this one, our first step would be add 2x squared to both sides and then graph it. You could have really done the Berry method or the quadratic formula or trial and error like guess and check with FOIL, but I would probably just graph it. So like when in doubt, graph. So 2x squared, plus 3x minus 9. Okay, there's our graph, and menu 6, 1 between here and here. That's your -3, 0. Menu 6, 1 between there and there. That's 1.50. So sometimes you will get a decimal which would not show up in the table. Again, that's why you have to do your multiple methods. And if you need to, press on and go over to the calculate or click, that part. And we want 1.5 menu number fraction. So that's 3/2. And then to get back where you were, press on and then do 4 for current. So now we're back. And this one you can tell from the tilt what we want. It was greater than, so it's above. And this one we want brackets on the numbers. So from -infinity to -3 bracket, and then from 3/2 to infinity. On this one, we have below, and we have brackets. X to the 3rd power minus 16x. Below, so that's left of -4, and it's also between 0 and 4. On our last one, this problem kind of combines what we did on the previous sections. You're going to want to graph it to get your zeros. We mean the real zeros, not the imaginary ones. Remember, if it said complex, it could be real or imaginary, but we just want the real ones in this case. So 2x to the 4th power plus 7x to the 3rd minus 87x squared minus 395x minus 175. Okay, so there is all of that. So then you do menu 6, 1. This one touches at -5. This one crosses at negative a half. It's negative 0.5. And this one crosses at 7. So first we just write down negative 5, negative a half, and 7. Then we do our factored form of it. And so if it's negative 5, we put x plus 5. And also on that one, it was touches, so that meant multiplicity 2. Now, on the x minus a half, or sorry, on the negative a half, we would have to take our denominator and put it in front. So in this case, put 2 in front, and then you put your x plus 1. You always change the sign. What's different about this one is they want you to put your term with your 2 right there instead of in front like we did before. So that's why this may be a little confusing. But remember, your denominator does go here, and just think, if you had a 2 here and a 2 there, that'd be 4, because 2 times 2, but we want 2. And then on the 7, we want x minus 7. So that's this part. And then you just pick your graph. The key part on that is to just change your y minimum and maximum. And then your solution set would be where it's between these two numbers. So again, you want below and use parentheses. Okay, hope that helps.